from a safety standpoint to ensure that when these trucks are in an aisle, the worst thing that can happen is an operator is 10, 12 meters high and somebody is underneath trying to pick something out of a pallet and now the truck moves. There isn't room inside the aisle for an operator to step out of the way. The clearances are so tight and the aisle is so small it's not possible. They're a very quiet audience. Does anybody have anything to say? With that said, all I can say is thank you very much for your time. And I'm finished. Have a question?
One is, what is the threshold? What are the thumb rules, let's say, for shifting from restruct to VNA as a technology, based on your experience?
Sorry, what are the...
What are the, let's say, parameters? A lot of the, let's say, a throughput of so-and-so, so much of pallet capacity of a warehouse, you should go for a VNA as compared to restruct.
Yeah, there's huge advantages in switching between the two. And I think one thing is to identify when you should be doing it and when you shouldn't. So let's talk about when you shouldn't. Grocery industry do a lot of picking. They do a lot of low-level picking. And the most important thing for low-level picking is 2 low-level pickers need to be able to cross in an aisle. So the minimum aisle width needs to be the width of 2 trucks plus clearance. That typically tends to be a reach truck aisle. So you'll be doing your low-level order picking at a certain period of the day, and then the reach truck will do drop-down replenishments in a later stage. That type of environment is one that is not suitable for converting to a VNA. Situations where you would, there are tremendous benefits. I really believe that from all of the trucks that we manufacture, the most difficult truck to drive is probably a reach truck. When you think about it, you sit on it sideways, you drive backwards, and it just seems counterintuitive to what you always believe. It's accepted in the industry, obviously, but when you look at moving to a very narrow aisle, with the cabin going up with the operator, you have visibility improvement. The truck guides itself, so the truck can't actually hit the racking. So you have the product damage reduction. Also can feature other improvements. Very often, it used to be the case that once a year you'd close your warehouse down and do stock check. And check each location and make sure it's there. You can do that with a radio data terminal system on a VNA truck now and integrate it. And when you're up in the air and you put a pallet away, it tells you to just double check how many boxes are on that pallet. And you can do it as a rolling thing over the year. So it's difficult because it's so much to do with each application, but I hope that gives you some idea of where it can and can't be used.
Yeah. Yes.
All right, thank you.
Okay. Second is on, in India, we have seen a lot of applications going to the ASRS. It's not completely automated. There's a man-up kind of machines. There are cranes beyond 15 meters, 14, 15 meters to 20 meters. It goes into manual ASRS, if I can call it so. So have you done any comparison, especially for the India market, and how does your VNA performs in the 15 to 20 meters area?
I'll be completely honest with you. ASRS, it was really popular in Europe, more in the 70s. It started to roll out in the 80s. Now it's a very specialist, and it's a market that's it's slowly disappearing. First of all, they're very, very expensive, so it's a big investment. The benefits that we offer with VNAs is a costing benefit. A benefit that you get from a ASRS system is it's top tide. Top tide means that you can get better capacities at greater height. Also means that you can get a higher travel speed at a greater height. But then technology is improving now where, for example, our equipment, as standard, it's not an option, it's a standard feature on the machine. When you pick a pallet up, it automatically weighs it and calculates how fast can I travel at height. At ground level, it doesn't matter because you can go full speed. But when you're at 8 meters and you drop a 1.5 ton pallet in the racking, once you've dropped that pallet into the rack, it now can calculate how quickly I can travel at that height and give me a better productivity. So as technology has been advancing, productivity on the V&A type machine has been exponentially improving. And I think the big backing to that is the fact that the man-down V&A market is disappearing. And the reason it's disappearing is that the only benefit that it ever had was it was a more productive truck. And it was more productive because it didn't have all of the slowdowns and speed reductions that the man-up unit used to have. But now with the CAN-bus type technologies, the integration in the systems, the intelligence that we're putting in the units, it's bridged that gap, and the productivity has improved such that that man-down V&A market really has been disappearing. So again, I think to differentiate between AS, RS and V&A, biggest factor really comes down to the cost. And I showed you the example of the order picker before, the 10.5 meter lift. Actually, that was an ASRS system. It was a company they were based in London. And I mean, real estate money, it doesn't get much more expensive than inner city London. And they were looking at an estimated £1 million per truck. And they'd got one truck in every aisle, 8 aisles. With our system, the customer ripped out all the railing off the floor. They poured a new floor. They replaced some of the racking that had been damaged by the old system. They cleared out an area at the back that allowed us to transfer from one aisle to another and replaced it with 4 trucks that were a much lower capital expenditure to the client, making a huge saving in their project.
Yeah, one last one on the energy efficiency or green technologies. Anything that you can share, the latest development?
When we talk about energy efficiencies, I mean, we still look at improving the energy efficiency within the motor technology. And a lot of the, again, looking at things like the V&A, it's to do with cycle times. So we typically look at about 2.7, 2.8 amps per cycle movement. So if you were to divide that into then your number of amp hours, I mean, you can get 1,000 amp hour battery on these type machines. You get an understanding of how many cycles you can achieve out of a single battery. So there is a huge drive for us to try to improve that continuously. And we do those with things like the regenerative lowering. When the cabin comes down, it recaptures that. And if you're looking at from a 17 meter lift height and you're lowering down and you're lowering at a speed of 0.65 meters per second, that's actually quite some time that it's doing that lowering. For us, the highest amperage consumption is actually the lift. Traveling, just like in a car, once you've got to a speed, actually uses very little current. And just getting to that speed depends on how hard you accelerate. And different parameters can be set on the machines. We also feature, it's an option that we have available on our warehousing equipment. You can use PIN numbers on the display unit. The PIN number can be configured to provide a different performance setting for operators. So you can actually control what performance an operator gets, and in turn that actually can control the cycle life of a battery. I hope that answers some of what you're asking for. Thank you. Anything else? Yeah.